Hi, this is Rick for EDU Mobile. Now we're going to talk about functions in Swift. This is a very big topic. You may not think that functions play a huge role in object-oriented programming. If you're coming from another language, Objective-C, we have C functions, let's say, but we don't use them or their syntax in objects class definitions. We use method definitions. Well, in Swift, methods really are functions. So it behooves us to look at functions and how they are coded in Swift. So here we go. So first of all, why functions at all? If functions, in the sense of C functions, are only used outside of objects, and if Swift is an object-oriented language, and if Swift will be used to develop iOS apps, and if iOS apps are built up out of objects and their relationships, then why study Swift functions at all? Why not just proceed to the whole method thing? Well, Swift method syntax is nearly the same as Swift function syntax. Functions also can be passed as parameters to methods and functions. Functions can be returned from methods and functions. So we see functions flying around all over the place in well-written Swift code through the methods of the classes. And functions can also be declared inner to methods and other functions. So functions take a step up in importance in the Swift programming language. Hope that answers some of the questions about why we're dealing with functions. So what's the function syntax look like? Well, we use the keyword func, and then we give it a name. There's a list of parameters, and then there is a return type. Now notice between the parameter list and the return type, we have an arrow operator. This says these parameters with this function name will return this type of object, or object. So here we have a function add, and it adds two integers, a and b, and it returns an integer. So we can see that this syntax says exactly what the function does. If we read it from left to right, func add, taking a and b, both ints, returning an int. And then, of course, inside the function body, we have return a plus b. Then we can call the function by something like this: let c add 3 and 6, and that will set c to 9. Now, of course, c is a let, it's a constant, so we can't then change the value of c, but that's only interesting at this point. We see how the function works. So here's an example of a function with no parameters and no return value. We're just telling the say hi function to execute a print line with the string hi. And here, lastly, is a function with a parameter and no return value. We're telling we define a print function to print the string that we pass in the parameter list. Parameters are constants. So the parameters of a function are constants by default. They are implied to have the keyword let in front of each parameter. We can place the keyword var in front of a parameter to make it alterable inside the scope of the function. But outside the scope of the function, if we only use the var keyword, a, in this case, is not altered outside the function. Let's say a was defined someplace else, and then we take in a and b. We multiply a times b, but then when we look at a outside the function, it has not been altered. We didn't return it, we just changed it inside the scope of the function, but it is not altered outside the scope of the function. And this is familiar to us. This is identical with the behavior of a C function. If we modify a variable inside a C function, then that variable is modified inside the scope of the function, but not outside. The only difference here is that, by default again, Swift function parameters are passed as constants, and therefore inside the scope of the function, they cannot be modified, again, by default. Parameters are also passed by value into functions. So by default, the value of a parameter can't be altered inside of a function's scope. And here we're talking about these primitive type parameters. We're not talking about classes. So if we set up a test variable called a test variable of type float and set it to 3.0, then we have a double this function taking a variable parameter a as a float and an a equals a times 2. Now if we call double this on test, it will still print 3.0. So the parameter has been passed by value. Even though we used a var, it still prints 3.0. Now, parameters are passed by value unless they are passed by reference. So we can also pass test as a reference value. And in this case, the value will be changed. And we do this by using the inout keyword. Now, we don't need to say inout var. Inout implies that it's a variable parameter. So a equals a times 2. Then if we say double this with a reference to test, and this is very important, we need that ampersand in front of the value that we're going to be modifying. Now if we print line test, it will print 6.0, not 3.0. Inout parameters are passed by reference. We use the ampersand operator to take the reference of a variable. The type of a function is the list of the types of its parameters and its return type. Why is this important? Well, in Swift, functions are typed according to the types of their parameter and the types of their return. And we can actually set up a variable using a function type instead of some other kind of type. So the type of add, a and b both ints, returning an int, is int in the parameters returning an int. Take two integers, return an integer. So if we set up a variable math function as being of type int returning an int, and then assign it the value of add, then we can use math function as an alias to the add function. This is a very simple example, and it's kind of hard to see why you would want to do this at this point, but believe me, there are situations in which doing this is a very cool way to streamline your code. So let sum equal math function 3 plus 4. Sum is going to be equal 7. Now, in Swift functions, we can also name our parameters. This is kind of like Objective-C, where the parameter lists the parameters in an Objective-C function are named. So here we define a function called subtract, a as an int, b as an int, but we apply a name to b from, and it returns an int. So we return b minus a. So we're subtracting a from b. And now we call this by using the name. Subtract 4 from 6. And this is really, really nice, because now our function says in its definition, in its call, exactly what it does. Make a variable, call it C, and make the value equal to subtract 4 from 6. Very cool. These are called external parameter names. Internally to this function, the parameter name for b is b. Externally, the parameter name for b is from. So external parameter names are used to clarify function calls. The above actually says subtract 4 from 6. If an internal parameter name is already good, then we can externalize it with a hash. Function reverse hash string as a string, returning a string. And then we can say let reverse string equal reverse string radar. So string is already a good name for this parameter. So let's go ahead and use it as an external parameter. External parameters, if they're defined in a parameter list, are required in the call. We can also have, in Swift, default values for parameters. So any parameter in our parameter list can have a default value. Now, for reasons that I'll discuss a little bit later, it's better to have these default parameters at the end of the list, but it's not required. So it just, well, it helps. So function raise, and here the idea is we're going to raise an integer to a power. If we use a default parameter, the parameter name for the default power, or the parameter name for the default parameter is made into an external parameter name for us. So when we call this, we need to say raise such and such to the power, and have to use that. Notice, though, that we have it as an int equal to 2, returning an int. We made this have a default value of 2. So inside we do our power function, and then outside we can call var c equal raise 3, and this will square 3. We can also call c equal to, or c raised 2 to the power 3, and this will give us back 8, of course, 2 to the third being 8. We can also have variadic parameters. A function may take a list of same type values as a parameter. So here we're finding the maximum of a list of integers. Notice that we've declared these all to be of type uint16, unsigned 16-bit integers, but we use ... to say, okay, I'm not giving you one of them, I'm going to give you a whole list of them, and then return the maximum. And we do our maximum function, it's pretty simple, and then we return maxint out of that, and then we can give a list in our parameter list, so let max equal find max of a bunch of unsigned 16-bit integers. And then max now will be assigned 19 because 19 is the highest integer in the list. The list that I've been referring to is actually called a tuple, but we'll talk about that next time. Because when we talk about tuples, we find out that we can pass them to functions like we have here. We can return them from functions, and we look at any value inside a tuple. Thank you very much.